Greetings! This is Daymarie D. Esterel, and for today, we are going to discuss about mathematics in nature and sets. Let's start with mathematics in nature. Pattern is a thing that is repeated or recurring arrangement, form or design following a rule or a sequence. There are 4 classifications of most common patterns in nature. The first one is symmetry. Symmetry is a pattern that shows reflection of images. There are 2 categories of symmetry, the radial and bilateral symmetry. Radial symmetry is a symmetry formed around a central axis. An example of this is a starfish. On the other hand, bilateral symmetry is a concept that 2 opposite sides have identical features. An example of this is a butterfly. The next classification is fractal. Fractal is a pattern which repeats at progressively smaller sizes and angles. Pascal's triangle is used as a concept in the transformation of fractals. It is a triangular array of numbers in which those at both sides of the rows are 1 and the others are the sum of the nearest 2 numbers in the row above. Other examples of fractal in nature are fern, snowflake, and aloe polyphylla. The third classification is spiral. Spiral is a pattern that moves around at a central point and continuously widening. Fibonacci sequence is one example of a spiral pattern. Some examples of spiral pattern in nature are seeds of a sunflower, giant wave, and snail shell. The fourth and the last classification is tessellation. It is a pattern that repeats figures closely fitting together with no gaps in between. Some examples of tessellation are polygonal packings, honeycomb, and pineapple fruit. Now, let's proceed to our next topic, which is all about sets. A collection of objects is called a set. The set is represented with a capital letter. The roster method. N is equal to 1, 2, 3, 4, 5, and so on, 100. The rule method. N is equal to x such that x is the set of numbers from 1 to 100. The symbol colon is read as such that. Set builder notation. Given a set A and P of x be a property that elements of A may or may not satisfy. A new set may be defined as the set of all elements x in A such that P of x is true. Now, let us proceed to universal set. It is a set that contains all the elements of the given set. It is denoted by U. Empty set. It is a set with no elements. It is also known as the null set. Subset. It is a set of elements that belongs to a set. Given a set X and Y, set Y is said to be a subset of set X if all the elements of set Y belong to set X. The cardinality of sets is the number of elements in a given set. Now, let's learn about set operations. The first set operation is union. A union B. Given 2 sets A and B, the union of the 2 sets is defined as the set of all elements that belong to either A or B or both A and B. The next one is intersection. A intersection B. Given 2 sets A and B, the intersection of the 2 sets is defined as the set of all elements that belong to both A and B. The third one is set difference, A minus B. Given a set A and a set B, the set difference of the 2 sets is defined as the set of all elements that belong to A and do not belong to B. Then we have complement, AC. Given a set A, the complement of the set A is the set of all elements in the universal set that do not belong to A. And lastly, the Cartesian product, or A times B. Given 2 sets A and B, the Cartesian product of the 2 sets is defined as the set of all ordered pairs AB, where A is equal to A and B is equal to B. So there we go. Now that we have finished discussing the topics about mathematics in nature and sets, I hope that you all have learned something from it that will be useful in solving future problems. See you again next time. Bye!